Hello friends, welcome to Shiksharthi. In this video, we'll be talking about quadratic equations. So let's start. So now, as you would have seen in my earlier videos, I have already talked about quadratic expression, and we have also talked about that there is not much of a difference, or will it be correct to say that almost no difference, except for the fact that in one case when I talk about quadratic expression, I don't equate it to something, and the moment I talk about a quadratic equation, I equate it to something. So in this session we are going to talk about roots, the roots of a quadratic equation. Okay, so starting off with the same thing, as we had started off when we started discussing quadratic expressions. So you would see, if I have written a quadratic equation, so the moment I say ax square plus bx plus c is equal to a 0, then alpha or beta are the roots of the quadratic equation. Now mind the words being used. We are saying if this is a quadratic equation, then alpha or beta. So I'm using a semicolon. So please refer to my earlier videos wherein I have already talked about the conversion of English into mathematics. Okay. So when we talk about roots, the other word that I can use for the word roots is zeros. So they are synonymous words. Whether I talk about the zeros of the function or a quadratic or an equation, or if I talk about the roots of an equation, they are nothing but the same. Okay, so here I had the equation and then we were boiling down to the roots of the equation. Right. Next, the point here is, if I talk about the converse of this, converse is if I say if A then B, then at the same time I can say that if B then A is the converse of a statement. So if somebody tells me that if alpha or beta are the roots of a quadratic equation, then what is the equation that can be formed because of these roots? So the equation that can be formed because of these roots would be A times of x minus alpha into x minus beta is equal to 0, wherein you know that A is nothing but the leading coefficient, which will always be a non-zero term, and the remaining coefficients, if I talk about B and C, they can be any number. When I say any number, the number can be real or imaginary, does not make any difference. It can be a 0 as well. Right. Third point, so you will see few things that we are talking about, we have talked about as of now, are those things which we have already talked about the time when I discussed quadratic expression. So all the things that I would have talked about quadratic expression, the moment I equate all those things to a 0, that means I am talking about equations. So the terminology factor is used only for quadratic expressions. Similarly, the roots and the zeros will be talked about when the quadratic expression is equated to a 0. Now here, what is the value of alpha? Alpha is one of the roots and beta is another root. So I can say that one of the root can be written as minus b minus root of delta upon 2a. Now what is the value of delta here? As discussed earlier also, delta is nothing but b square minus 4ac. This is the value of delta. So one of the roots, which is alpha here, will be given by minus b minus root delta upon 2a, and the value of the other root is minus b plus root delta upon 2a. Now please bear in mind that the roots will be either this or this. Now why do I say this? Because both of them at the same time cannot be equated to a 0. Now what do I mean by this? I mean to say is 0 into 0 is not equal to a 0. Right? So 0 into a non-zero term will be equal to a 0, which is why you will say that at a time only one of them will be a 0, which is why we are using a word like or. Now if both of them can be used as a 0 at the same time, we'll use a word like and. So please bear in mind, when you are talking about a quadratic equation or any equation which is having two or more roots, you'll always use a word like or. You will never ever use a word like and. Right? You can always refer to my other videos wherein we have talked about the usage of or and and. Please refer to those videos. Okay. Now at the same time, so if alpha or beta are the roots of a quadratic equation, how can I form an equation? The equation can be written like this, wherein it is nothing but a times of x square minus the sum of the roots times x plus the product of the roots, which is equated to a 0. So if I were to rewrite it, I can say this is nothing but a times of x square minus sx plus p equated to a 0, where s is the sum of both the roots and p is the product of both the roots. I hope I have made my point clearly. Next, so taking this discussion forward, when I talk about roots, right, which are nothing but the zeros, the roots will be either real or non-real. So now is the time wherein we need to integrate. We are already over with the basics, because the basics we have already discussed in these 3 sessions, in these 3 videos. And now is the time wherein we need to integrate this topic with numbers, right? Okay, so now when I'm talking about roots, and we are talking about roots of a quadratic equation, the roots will be either real or non-real. Now when I use a word like non-real, the numbers are either real or non-real. Now the word non-real here becomes imaginary. So the roots will be either real or imaginary. So taking this discussion forward, now when I talk about roots, and I know in a quadratic equation I can have maximum 2 roots, in that case, if I have to write this as a sum of 2 numbers, so please take it like this, that the total number of roots are 2, and these 2 roots have to be divided among real roots and imaginary roots. So will you get 3 cases here? If you recall, we talked about a quadratic expression being a trinomial. Why trinomial? Because we are able to write it like this, 3 cases. Anyway, so coming down, now 2 can be written as 0 plus 2, wherein 0 real roots and 2 imaginary roots. Is this case possible? Yes, this case is possible. Similarly, can I have a quadratic equation which has 2 real roots and 0 imaginary roots? Is this case possible? Yes, it is. But can I have a quadratic equation which has 1 real root and 1 imaginary root? No, this is not possible. Why? Because imaginary roots always exist in pairs. We'll talk about this later in our subsequent videos when we talk about imaginary roots. As of now we are focusing on the nature of roots without using discriminant. Discriminant we'll talk about in the subsequent videos. Taking this discussion forward, now I know that I can take this as a case wherein I have 2 real roots. Now taking this discussion forward, which is just like saying a quadratic equation having 2 real roots, and doing a micro analysis of this, right? We are doing a micro analysis on the number of roots, and the roots can be divided into what? Real numbers, imaginary numbers. Real numbers can be further divided into rational numbers, and irrational numbers is what we are going to discuss next. So I know a real number can be written as, a real number can be divided into 2 parts. One is rational part and the other one is the irrational part. Similarly, real roots can be divided into rational roots and irrational roots. Again, the breakup would be 0 plus 2, 0 rational and 2 irrational. Is this case possible? Of course. Can I have a case like 1 rational root and 1 irrational root? Of course, yes. Can I have a case like 2 rational and 0 irrational roots? Yes, I can. I hope now till this point we have talked about what? We have talked about what is a quadratic equation, talking about the roots, what are the roots, we know the values of the roots as well. We also know that both these roots may or may not be equal, as already talked about in quadratic expressions. So if I know that had these 2 roots been equal, and if I have to write down an equation of, if I have to write down the quadratic equation which has both the roots equal, how can I write it as? I'll write it like a times of x minus alpha into x minus alpha, which is nothing but a times of x minus alpha whole square. Now we have started something very innovative. Now what is the innovative part that we have started? So you would see that in the description of videos, we are giving you a link of our website wherein we will post questions, and you can visit the questions as a site visitor, solve the questions and discuss the questions there itself. So check for the link in the description of the website. So that is a forum wherein we'll be putting questions on maths, English and reasoning as well, based on whatever we would have discussed in the videos or from elsewhere. So if you feel that this video was really informative. Please do not forget to like, share and subscribe to our channel. If you have already done so, please click on the bell icon and select all so that you start receiving updates on a regular basis. Thank you so much. Until next time we meet, goodbye.